So in this session, we will start with the exceptional handling and then we will move to models and
Mhm.
packages. Okay. So we have another important concept which is known as exceptional handling. Now, what is exceptional handling? It is like a method or we can say a mechanism of handling the errors in Python. As we can see, up to here, we have faced many errors. Like we have dealt with many errors. There are like many types of errors in Python. We have syntax error, we have indentation error, we have like all sort of errors. So in Python, we have something known as exceptional handling, which can handle the errors. Let's say you are creating any program, and let's say there's something, let's say you are taking input from the user and let's say the user enter any other, let's say you are taking input as a number and the user applied any string or any character or any alphabet. So in that case, your program will throw the error. And in that case, your program will stop working. So in that case, you have to handle the error gracefully. Otherwise, your program will stop working. And that is not, that is not, uh, that is not required. And that is, you don't want whenever you are creating any software or any user is using a software. So handling the errors are very important. Like if there's any error from user side or from your code side, that should be handled. And then your code should not break in the middle of any input or anything because of some error. So that is why we have to handle the errors. And how we can handle errors? That we can handle with the help of try and except block. So we have two blocks in Python. You just try and accept. So the try block lets you test a block of code for errors, and accept block lets you handle the error. Okay, for example, so we have four types of block. We have try and accept. These are important.
Mhm.
Without try, you cannot handle. Without accept, you cannot handle. Then we have
Mhm.
else block and finally block. Okay, else block and finally block are optional here. So when an error occurs or exceptional, as well as we call it, Python will normally stop and generate an error message. So we don't want that Python code will stop. So we want the Python code will run up to the entire length or up to the end without any without any break. Because whenever we are having any error, we are Python face any error or it generate any error, the Python code stop in the middle and that we don't want. So that is why we want that if there's any error in the middle of any code, the Python will not stop working in the middle. It will stop up to the end. Okay. So that is why we have this exceptional handling. For example, we have this example of try and accept. We can write try and print x and then accept print an exception occurred. See. So we can create a new file. So we have this try. In the try block, if everything goes fine, then the try block will execute. If there's any problem, then the accept block will execute. Okay, so first let's write print x. Okay, then here we can write accept. If there's any error occur, then we can write print and error occurred. Okay, let me save this file on desktop. Let's say uh, exception underscore handle dot c. Okay, now if we have the value of x, which we don't have, because what we are doing, we are printing the value of x. And we don't have
Mhm.
x now. We have not defined x. So this line of code will not execute, and this line of code will execute, which is the except block. If I run this one, you will notice an error occurred because we don't have the value of x. If I write here the value of x equal, let's say 5. Now we have value of x. So if I run this one, you will notice 5 here. So because what we are doing, we are just defining x as a variable and here we have this 5. Now we are running try. So in the try block, we are saying that print x. So if any x occurred or if there's any x variable, then that will print the value of x. Otherwise, if not, then this will print an error occurred. So if everything goes fine, if there's no error, then try block will execute. If there's any error, then except block will execute. That is the flow of code. Okay. We can also run multiple exceptions. Like this is one exception. We can run multiple exceptions. Let's say we can run here try. Okay, this is second example. And here we have this print. Let's say hello. We can write here hello. Okay, now you can see without try, if I comment this out, yeah. So you can see without except, we cannot use try. If I run this one, you will notice an error here. Expected, except, or finally block. So without try, without except or finally block, we cannot run try. So singly, we cannot run try. So either we have to run except or finally block. So that is like they go together. So we have this except here. Now in the except, we can write something. Let's say print. We can write something went wrong. Let's say this is my one exception. Second, I can also write another exception. Let's say print. Sorry. Here we have to write else. So, print nothing went wrong. So here we can write try and print hello world and except, which is print something went wrong. If anything went wrong or if there's any error, then this line of code will execute. And if there's no error, then this line of code will execute. And if there's an error or like if there's any, sorry, if there's no error, then this line of code will also execute. So we are running try and except block with the else condition. Else condition will execute when try block will execute. If I run this one, you will notice first hello world and second nothing went wrong because there's no error. So try and else block will run together if there's no error. And if there's any error, then this line of code will execute. Let's say if I write something, I forget to use a quotation. And if I run this one, you will notice it is a syntax error. So that will not, let's write y. Y is not defined. If I run this one, you will notice error. Something went wrong because y is not defined. So that is why this line of code will execute. If everything goes fine, then try will execute and else will execute. Okay. Let's say I can use let's say again y, and we can define y here. That's a y equal 1. Now we have this y which contains 1. So here 1 will execute and else block will execute. 1 and nothing went wrong. So we can use try, we can use except. With the try and except, we can use else block. So else block lets you execute code when there's no error. So else block will run with the try block. Then you just finally block. So finally block lets you execute code regardless of the result of the try or except block. So if there's any error or if there's any no error, finally block will run. Okay, so if I show you, let's say we can comment this out. Let's say we have this one, which is try block. In the try, I'm writing hello world. Okay, there's no error till now. And let's say we can write here except print. We can write something is went wrong. Okay, then we can run a finally block. Finally block says, let's say code completed. Okay, so if I run this one, you will notice first hello world and second finally block, which is code completed. So no matter what, if your code runs successfully or if there's any error, finally block will run. Okay, for example, if I type here Z. So there's no variable named Z. Okay, so if I run this one, you will notice first error, which is something went wrong, and second, finally block. Code completed. So if I run this one, you will notice something went wrong and code completed. So finally block will run no matter if there's any error or not error. Okay, but try block will execute. Let me write here. Try block will execute if there's no error. Okay, then we can copy this and we can write in the except. Then except block will execute if there's some error. Okay, else block will execute. It will execute if there's no error. Okay, if there's no error, then else block will execute. And finally block will execute if there's error or not. Okay, so regardless of we have error or not, as finally block will execute. Okay, let's say if I define value of z 5. Now we have z. Then we have this value of z, which is print z, and then we have this finally block. Okay, which is let's say 5 and code completed. Okay, so that is why we have 4 statement here. Is it clear?
Yes, they are clear.
Then we have something known as raise an exception. So we can also raise an exception. Okay, let's say we have this value. Like raising an exception means, let me give an example first. We have this value of x, which is -1. Okay, now we can check if x is less than 0. Okay, which is minus. Okay, if x is less than 0, then you can raise an exception. And what that exception says that, sorry, we can write something here, sorry, value, or we can say negative values are not permitted. Now here you can see there's no syntax error. There's no error here actually. There's no syntax error. There's no indentation error. There's not any error which Python can handle. Okay. So, but here we are generating our own error. Okay, the user is generating our own error. That is, if the value of x is less than 0, then forcefully raise an exception that, sorry, negative values are not permitted. If I run this one, you will notice, sorry, negative values are not permitted. You can see raise exception value, negative values are not permitted here. So this is the error generated by user. Okay, if I run this simply, let's say the value of x is -1. Okay, so value of x is -1 is allowed. Okay, we cannot say that -1 is not allowed in the Python. It is allowed. If I run this one, let's say if I run this value of x, and for now I am commenting this, and if I run this one, you will notice -1 is permitted here. But what I just want to generate an error, like a forcefully, I just want to have an error that if user applied any number which is less than 0, then we will generate this error. Let's say you are taking input from the user. In this place, you are taking input from the user. Let's say int, we can write enter the number. Okay, in the else block, we can write something else. Else print x. Okay, now let's say if I run this code, Python, what is the name of first section? Okay, so it is asking enter the number, let's say 6. So see, 6 will be printed. But if I enter a number like -2 here or -1, you can see we have an error. And it is not actual error. It is like an error generated by user that, sorry, negative values are not permitted. So in this way, you can generate your own error. If this, see in Python, we have lots of error. In Python, we have lots of built-in errors. But let's say you want to generate your own error, your own kind of error. Then in that case, you can raise your own exceptions with the help of this keyword raise an exception. And this is the error. the error message you want to generate. Okay, so this is raising an exception. This is one way of raising an exception. We have another way of raising an exception, which is by creating user defined exceptions. Okay, so in the Python, we have two types of exceptions. First is the Python built-in exceptions, and second is Python user-defined exceptions. If I show you, here you can see these are the Python generated Python built-in exceptions, like Python errors here. For example, we have this assertion error, attribute error, EOF error, floating point error, generator error, import error, keyword interruption error. We have this syntax error, you will notice here. Syntax error, indentation error, tab error, system exit error, and so on. Like we have many errors here in the Python. These are all Python self error, like Python built-in errors, which is provided by Python. Okay. But we can also generate our own error. We can also create our own error with the help of user-defined exceptions. And this we can do with the help of class and objects. So what we can do, I can create a class known as my error. Now this is my error, which will take exception as a parent class. Now what is parent class? See, my error is a child class. Why it is a child class? Because it is taking features, or we can say attributes or methods from the exception class. It is a part of a advanced oops that we will discuss later. But for now, understand that here we are providing exception. It is another class. So I am providing another class to my error class, which means my error class becomes the child class, and this exception is a parent class. And this exception class is somewhere else in the Python. So we are taking some features from the parent class. So we become a child class. Okay, we will discuss this concept in detail in later on. But for now, understand we are taking some features and methods from the exception class. So we become a child class. Okay, because exception is a parent class here. Then here we can create an initializer, which is underscore underscore init underscore underscore. And here we can take self and a value. Okay. Then we can identify self dot value equal value. Then we have another function which is known as def underscore underscore str underscore underscore. Okay. Here we can again use self, and here we can return self dot value. Okay. Now this is my class, simple class. Here I can use a try block, try, and here I can raise the exception, which is my error. Okay, my error means my class. And here let's say I'm providing a value. Let's say 3 multiplied by 2 here. This is my value. And here I can use except block. Again, simple except block. So it should be in a small case. Okay, we have this except block. Now in the except, I'm providing that my error is error. And here I'm printing some message. Let's say a new error or exception. Okay, simple. So here, see, first we have this class. If you want to create your own exception, then you can create in the form of your class. We have class, and class is my error, which is the name of my class. And this class is a child class because here I can write it is a child class. Okay, which means my error, which is this one, is a child class because it is taking properties and methods from the parent class. And what is parent class here? Exception. Exception is a parent class. My error is my child class. Okay. And here we have this initialization function. We are initializing a value which is self. Sorry, a value here. Okay. Now we have this another function which is known as underscore underscore str underscore underscore. This function is mainly for printing something. That's it. Okay. This function is for printing something. That is the whole purpose of this underscore underscore str underscore underscore. We want to print something. That is why we are using underscore underscore str. Then we have this return self dot value. So we are returning this value here. Okay, value. And then we are creating the try block. In the try, we have this raise. And now here we are raising an exception which is known as my error. My error is my own exception, which is my class here. And then here we have this value which is 3 into 2. And then here we have this another except. Now here we are using except my error as error. Okay, this is my own error and print a new error occurred. So if I run this one, you can see a new error occurred because here we are providing any other value. We are providing a numerical value. If I put here single value, you can see a new error occurred. So no matter what we put, this will throw the error. Okay, because we are just creating a class which contains the error. Okay, if it is not like clear, so don't worry, we will clear in the later session when we will study inheritance. In the inheritance, we have this concept of classes. Sorry, we have this concept of child class and parent class that we will discuss. Okay, but for now, if I will say the definition of this particular part, you can see user-defined exception. Programmers may name their own exceptions while creating a new exception class. Exceptions need to be derived from the exception class, which we have derived from here, exception. Exception is my parent class, either directly or indirectly. Although not mandatory, most of the exceptions are named as names that end in error, similar to the naming of the standard exceptions and error. Here we have raised here my error as error. So we can always put my error as error, but here you can put any name. But the common practice is we put my error as a naming here. Okay, and here we can put error dot value like this one. Here we can put our error dot value, which will show the error here. Okay, you can see a new error occurred and the error is 3 because we have applied this value 3. If I multiply this 3 into 5, so we have this 15. An error occurred which is 50. Okay, so this is just an example like how we can create our own error. Later on we will create, then you will understand the power of the classes and how we can create our own error. But for now, just make sure that you understand this concept, which is here we are creating a class, which is my error is our child class and exception is a parent class. And then here we have this def. In it, we are initializing a value. Okay, and then we are printing the value. That's it. Okay, this is for initialization and this is printing something. We are printing the value, which is we are returning the value. Now, value can be anything. It can be any calculation. It can be any single value. Okay, here we are providing a calculation, which is 3 into 5. Okay, so it is a simple calculation. And then here we have this accept my error as error. And here a new error occurred. And then we are printing the value, which is error dot value. So whatever the value feed here, we are printing here. Okay. Is it clear?
Yes, teacher.
No. So this is user defined. Then we can generate many exceptions. Okay. Let's take an example of try. Let's print here simple X. Here we can generate many errors. Okay. Let's say except. Now here we can generate an error known as name error. Now this name error is Python error. Like it is built-in errors, which is provided by Python only. Here we can provide a value, which is variable X is not defined. This is one type of error. Let's say we can face another type of error. If the error is not name error, then we can put another except block here, which is something other went wrong. Okay, let's see. And here you can see if I run this one. Now this is a name error. You can see variable X is not defined because this is a name error. Name error means if there's a variable which is not defined, then it is a name error. Let's say if I define value of X, equal 5 or 6. Then you will notice value of 6 here. Okay. Now let's say we can just put here nothing. Now it is a syntax error because we have this x here equal, but we are not providing any value. So this will throw the error. So if I run this one, you will notice invalid syntax. So it is a syntax error. Let's say if I put something else, let's say 6 comma 7. I think this will not throw the error. No, it is a tuple. What we can do, let's say G, like this one. Now G is a syntax here. Okay, but here I'm not providing the quotation. So it is a syntax error. Okay, name G is not defined. So again, what we can do, can put any number here. I just wanted to print this something other went wrong. What we can do for that? Let's say if there's any error, we can also generate any other error. Let's say syntax error. Okay. So here I can write this syntax. Okay, now we can generate a syntax error. Let's say here. Now x equal, there's no value here. Now the syntax error will run. Okay. So you can see invalid syntax. Now invalid syntax is a built-in syntax. So that is why Python is not printing my line. Python is printing its own syntax error. That is why we have this invalid syntax. Okay. But if x is not defined, so this will throw name error, which is variable x is not defined because variable x is not present here in my code. So that is why variable x is not defined. If let's say if we define variable x and we can, let's say if I remove this part, again it is a syntax error. Yeah, it is a syntax error. So maybe we can put any other line here. Okay, maybe we can put any other error so that we can generate this line also. Okay, like it is an example like how we can generate multiple errors. Let's say if your code is running and anyhow it stopped running by any other error, like any memory error, any keyboard error or anything, then this line of code will execute. Okay, this any other error which is not defined by Python, then this line of code will execute. Okay, otherwise name error will execute when x is not defined. If x is defined and if there's any other error, then this line of code will execute. Okay, and that error should not be known by Python, like any unknown error from nowhere. Then we can run this line. Okay, we use try or except whenever we are debugging our code. That is very important. Like when we use try or except block, we use try or except when we are debugging any code. Debugging means whenever we are checking the code for errors. That is debugging. Debugging is a process whenever you are checking your code line by line that if there's any error or not. Sometimes your eyes miss the error, like there's a syntax error or there's any other kind of error. So maybe sometimes you miss the error. So in that case, debugging is helpful. Even we have this one feature in the Python, which is you can see run, start debugging. Debugging is like a kind of you are checking your line code, you are checking your code line by line that if there's any error or not. If there's any
Mhm.
error, then your code, your this debugging part or mechanism will show that line if there's an error. Even sometimes this debugging also skip the value or skip the error. That is why we use try or except block to show the error. Like if everything goes fine, then your try will execute. If something went wrong, then except block will execute. And in that case, you should know, okay, there's an error here, which means whatever you are doing, let's say you are writing a function or you are writing a loop, you are writing anything, you are creating your own class. Try to put your classes, your objects, your functions in the try or except block. Okay, for example, if I define here print hello. Now let's say I just wanted to check if there's any error in the function or not. It is a very small function. Let's say this is a function of 100 lines. So I cannot check line by line. So that is why I can put this function in the try block. Okay, I can put this function in the try block and then accept. And here I can print something. went wrong, like this. So if there's any function error in the function, then this line of code will execute. So in this point, I know that, okay, there's an error in my function. Okay, so this is like a way of identifying the error. Let's say you are debugging a large line of code or a very long code. Then in that case, try to put try or except block. Or let's say if you are not finding your error, like where's the error is. So try to put try or except block and try to put your code in the try, and in the except you can put your error. Okay, let's say there's a x here. Okay, now we can call the function here. Let's say print, no, function here. Here I'm providing a parameter, but I'm not providing a value here. So I think this will not generate error as our. So we can define a value. Let's say we can print here. Let's say the value of x. Now x is not defined. Okay, x is not defined. So here I can remove this. So here x is not defined here. So if I run this one, you will notice nothing because we have to call the function. So let's call the function here. Now we have this error, maybe something went wrong. Okay. So you can see we have two errors here, first error and second error. So first error is because of this name error, which is name x is not defined. Okay, so there's an error. It is a very common error, which is name x is not defined. That is why Python is generating its own error. But if there's any error which is unknown to the Python also, then this line of code will execute, which is something went wrong. Okay, which is here x value is not defined. Okay, or let's say if x is a local variable or a global variable, then that problem will occur. Okay, but here now just understand that whenever we are debugging the code, we use try or except. Whenever we want to find any error, we can use try or except block. Whenever we are taking input from the user. And let's say the user, you are taking input as a name. You want the user to put their name and the user is putting some number. In that case, your code will break. So in that case, you can also generate the error that numbers are not allowed, name are allowed. That in that case, you can raise the exception error that numbers are not allowed, only alphabets are allowed. Then in that case, you can also raise an exception, your own exceptions. Okay, so using try and except will not not block, not break your code in the middle. Okay, otherwise, if I show you an example, let's say we have a for loop for I think range from 1 to 6. Okay, let's say 1 to 5. So here I'm just printing value 5. So this is my simple for loop. If I run this one, this is my simple for loop. But let's say before for loop, I am defining something. Let's say print value of x. Now you can see x is not defined here. Okay, there's no value of x. There's no x here. So if I print x here, first I'm printing x and then I am printing for loop. So my for loop will never execute because there's an error in line number 74. If I run this one, you will notice name x is not defined. So whatever is after my 74 line, that will never execute because we have an error at line number 74. That is why. But here, if I use try or except block, here I'm using try and except here. And here I'm saying just, let's say something is off, let's say. So now my for loop will never stop. Okay, like first write this print x. Now again, print x is not defined because x is not there. So this line of code will not execute, but except block will execute. And also my for loop will execute because I'm using try or except. So with the help of try or except, your code will never stop working. So if I run this one, you will notice something is off. And here we are having the for loop also, which means if there's any error or not, your code will not stop working. Okay, after the error. That is why we mainly use try or except. Let's say if there's any error in the middle of your code, then the whole code will stop working if you are not using try or except. But if you are using try or except, then your code will never stop working up till the end. Okay, which means the code will never stop till end. That is why we are using try or except. Okay, here we are using try or except, which is where this something is off and we are having this fall. But if I simply remove this try or except, okay, and if I simply print the value of x, now there's an error. Okay, but this time the code will stop working. You can see there's no output of fall because Python suddenly break your code because Python works from top to bottom, from line by line, from top to bottom. So that is why when Python come at this line, Python sees, okay, there's an error and Python suddenly stop working. No matter if there's any other code under your error or not, no matter, it will stop working. So that is why we mainly use try or except so that we can avoid breaking the code in the middle. Is it clear?
Yes, teacher.
So this part is important. Then we have
Mhm.
last concept in the try or except block, that is assertion. Assert. Assert keyword. Now, assert keyword, let me show an example. The assert keyword is used when debugging the code. So the assert keyword is lets you test if a condition in your code returns true. If not, the program will raise an assertion error. So you can see assert is like a one line error. It is like a one line error. And if your condition is true, then no error will generate. But if your condition is false, then this error will generate. For example, with this hello here, okay, x equal hello. So if condition returns false, assertion error is raised. Here we are raising assert x equal goodbye, x should be hello. So let me give an example. X equal, let's say, we can print something, let's say hello, just let's say for now. Now here we can check a condition on the fly. Let's say we can use assert. If assert of x equal hello, okay, then x is, we can put here, x is hello. Okay, if I run this one, you will notice x is hello. Like there's no error here. Why there's no error? Because we have this value. Let me put a number here for now. Okay, let's say value is 4. And here I'm putting 4 here. Now x is 4. So we are saying, okay, the value, if the value of x is 4, then return true. Otherwise, return false. Now value of x is 4 only. So that is why we have no error here. Because value of x is 4. What if value of x is 5? And we are checking for the 4. Okay, then this line of code will execute, which is x is not 4. You see, x is not 4 and it is a kind of a assertion error. What is this error? It is saying that if there's any error, if there's any condition which is false, then this line of code will execute. This line. If the condition is true, then this line will never execute. If let's say if x is 4 only. So this condition, and now this condition is matching because x is 4. So there's no error here, no error at all. But if value of x is not 4, it is something else. And we are checking for the 4 only. If x is equal to 4, then this line of code will execute, which is x is not 4. You can see assertion error, which is x is not 4. You can see it is a one line condition we are checking. Okay, previously we are writing a whole lot of code, but here we are checking in one line if value is true and false. Okay, if the value is true and false. If the value is true, there's no error at all. But if the value is false, or if there's condition, if there's any code which is not running as per expected, or if the condition is false, then this error will like throw. And this is a one line error, or we can say error in the fly. Okay, so this error is like come handy whenever you are debugging your code. Let's say you have many conditions in your code, let's say hundreds of conditions. Now you cannot sit back and you cannot check each and every condition. That is why you can put your assert error there. That if there's any error, then please return this keyword or any keyword. Let's say we can say return false, simply false. And if everything goes right, it will not return anything. Okay, you can see false here. If everything is right, like let's say value of x is 4 only, then there's no error here, no output here, which means everything is fine. But if there's any error, let's say if value of x is not 4 or anything, then we have this error here, which is, you can see, assertion error,
Mm.
which is false. Okay, so that is why assert is helpful. It is for mainly for generating one line error. Okay, the syntax is also very easy. Is it clear this much?
Yes, teacher.
Okay. So this is all about try and accept block, or we can say exception handling. So
Mhm.
let's take a recap. So in the try and accept, we can use four statement: try and accept. Try and accepts are compulsory. Apart from that, you can also use else or finally. Try will execute when there's no error. Accept will execute when there's any error. Else block will execute when there's no error. Finally, block will execute when there's error or not error. It will execute regardless of error or no error. Okay, then these are some examples. We have this many exceptions. We have this else block and finally block. Then we can also raise your own exceptions. If there's any error which is not defined, then you can also raise your own exception on the basis of condition or on the basis of any parameter. Then we can also create our own errors. We can use assert here. And here are some default errors. Okay, some Python default errors like assertion error, as we can see, attribute error, EOF error when there's any some value error, floating point error when there's any decimal error, generator error, import error, index error, key error, keyboard error, and so on. So these are some errors. So after this class, try to read these error. Okay, just read it. It is not compulsory to fully understand. Just read how many types of errors are there in Python. Okay,
Mhm.
so is it clear? Any questions till now?
No, teacher. There's a lot
Okay.
of errors.
So now we can move to another part which is known as module and packages. This is another important part of Python. Now, what are
Mhm.
modules or what are packages or what are libraries? So we have these three terms. So here in Python, we have package. Package contains all the files you need for a module. Modules are the Python code libraries you can include in your project. Now, let me clear this part. So here we have this package, we have module, we have library. Basically, these are all uh, like same, but there's a slight difference. First, in the Python, we have a simple code, okay, or we can say simple Python file. For example, this one. This is a simple Python file, a simple single Python file. Okay, it is a simple and single Python file which contains some code here, right? So this is Python file. So combination of multiple Python files are known as packages, or we can say libraries, which means combination of multiple Python files are known as packages, modules, or library. So here we can see package contains all the files you need for a module, which means package contains multiple Python files. For example, previously we discussed about OS module, right? OS module, operating system module. So operating system is a module which contains multiple Python files. Okay, that is known as a module. Or we can say a module can contain one file or a multiple files. But module is like you can see, module is a like a Python file which is pre-coded by someone else. So module is a Python file which is pre-coded by someone else. Okay, which means module is a Python file which is pre-coded by someone else, like any developer. And now what we can do, we can use their functions, their methods, their variables in our file without actually coding it. For example, let's say if I import here OS. Okay, we are importing a OS. OS is a module here. Okay, OS is a module here. So we are importing OS here. Now I can use any kind of command here. Let's say I can use here print, I think OS dot, there's a sysinfo, system, let's say. This will return the system type, I guess. No, let me remove this thing. Yeah, you can see it will returning some part here. So you can see os.system. System is a kind of a function which is inbuilt in the OS. Let me show you the file of os.py. See, os.py, right? If I open this file is inside your operating system. So in your Python. So this is the OS file, right? Now this OS file contains many other part. This is a whole file. And you can see it contains many common functions and methods. For example, there's a function here, namely exist. There's another function, namely mkdir. This is for the making the directories, for making the folder. This is for removing the directories, removing the folder. This is for renaming that we have used. We have this walk here. This is something else. Okay, you can see we have these predefined functions, and these are functions only. Okay, without calling them. These are the functions which is defined in this file, and now we are using these defined function in our file by importing it. So you can see
Mhm.
importing means we are importing the functions, whatever is there in this file, we are importing from this file to our file. Now I want to use, let's say I just wanted to remove any file. I just wanted to remove anything, any file, let's say. So I will name my file, let's say sample.txt. It is my file. So now how I am removing this file, how I am operating my operating system with the help of Python. That is because of this OS module. This OS module contains some predefined code. Okay, it is all a predefined code. And now we are using this code in our file. And this code is written by someone else. It is written by or coded by someone else, like any developer, because Python is an open source language. They're like many developers, they came and they contribute in the Python language so that we can use Python in various purpose. Like we can use Python libraries, we can use Python modules, we can import modules and so on. Now let's say if there's no library known as import OS, then what we can do? How we can remove it? How we can remove any folder or file? Then we have to code the entire function first and then we can remove it. But in the OS here, in this file here, we have predefined functions. We have predefined functions. For example, we have this function of where rename or remove. You can see remove directly. So we have this predefined function. It is a function only. Okay, a simple function. But how we are using this function? We are using this function because of this OS file. You can see OS is name of my file, os.py. And that is what I am importing. Import OS. Okay, it is a pre-built module of Python. What is pre-built? It is coming with the Python only. Whenever you install Python, it is coming with a Python only. If I show you some modules in Python, I think we have a folder here. You can see module in Python. Okay, I think this is for the TensorFlow. If you can check out for the side packages. See, these are some modules here. These are all libraries which are installed. Let me check for the modules and packages. These are all libraries. Okay, these are all libraries. What are libraries? Libraries are combination of files. Okay, which is combination of multiple Python files is known as library. Okay, is known as library. And what are packages? Packages are same as library. You can think of packages are like combination of libraries are known as packages. You can think. But packages and libraries are same only. Somewhat they are same. Okay. So here this module. Module is a single Python file which is already coded by someone else so that we can use the feature of that file in our code without actually coding the file. And then we have this library. Library is like combination of multiple Python files. That is known as library. So here we have this modules and this definition is not correct. So let me correct. Okay. So we have this module, which is a single Python file, which is pre-coded by someone else. And library is like a combination of multiple Python files. So we have two types of module. We have this built-in modules, okay, like OS, date time, and so on. Random module, it is another module, and so on. We have many modules here. And we can also create our own module. Okay, we can create our own module. So let me show you an example of a module here. Okay, a simple example. Let's say let's say I'm creating another file. Okay, a simple file, a simple Python file. In my Python file, I am creating a function. Okay, a simple function, let's say function, which will multiply two numbers. Okay, let's say it will multiply A and B together. Okay, it is my function. Now, as I said in the functions, function defining is not enough. We have to call the function also. If I save this file, let's say file one, okay, file underscore, let's say m dot py. This is my file name, file underscore m. Okay, so this is my function. If I run this one, you will see no output here because function defining is not important. Okay, like function defining is not enough. We have to call them also. So how we can call it? So I'm not calling this function here in this file. I will call this function in my another file. Let's say in my this file. So what I will do, I will import. I will import file underscore m. What is file underscore m? File underscore m is the name of my file. You can see file underscore m. Now this becomes a module here. Okay, now I can call my function here. Function, I can call print function and I can provide two values. Okay, here I can use file underscore m dot function. Now if I run this one, you will see 5 into 4, which is 20 here. See the magic here. I am not defining the function here. I have not defined any function naming function, which is func. I have not defined any function with the name of func in this file, but I have created a function with the same name in another file. What I am doing is I am importing this file, which means importing means I am importing this function in my another file by importing file underscore name. File underscore m is name of my file. I am importing. Importing means I am importing or I am importing the functions, or we can say the code of this file, which is file underscore m. Now what I can do, I can use this function in my another file by importing it. So this is the name of my file dot func. Func is the name of my function. And here a and b are value, which is 5 into 4. So this will multiply 5 into 4. This is an example of a module. Now my this file becomes module. If I create another function, let's say function 1. Let's say it will not take anything. It will simply print hello world. This is another function. Okay, in my another file. But what I'm doing, I'm importing file underscore m. And now I just want to use this function again. Because if I run this file, you will see no output here. Because here I'm defining the function. I'm not calling it. I'm defining the function. I'm not calling it. So this file is show no output. But I'm calling this function in my another file. Here, I will use function file underscore m dot function 1. Now here you will see hello here. Hello world, which
Mm-hmm.
is the output is showing here. Hello world. So which means my file underscore 1 becomes a module. Why module? Because I'm using this their function in my file. Okay, let's say I have this example, this dictionary. Okay, so let me copy this code. In my file underscore m, I have this dictionary here. Dictionary of persons, name, age, and country here. So now what I can do, I can use this dictionary in my own function. So what I can do, I can print person underscore, sorry, file underscore m dot person one. What is person one? Person one is name of my dictionary. If I run this one, you will notice my dictionary. Name John, age 36, country Norway. Here I'm
Mm.
not defining any dictionary in this file. I'm not defining any dictionary. My dictionary is in another file, in this file. So I'm importing this dictionary in my file, in another file. Even I can extract name from my file. You will see name John. You can see John here. File, I guess name, no module name. Okay, so we can, I think, extract, sorry, we have to put a square bracket like this one, name here. Okay, now we can extract John, only John, from the entire dictionary. In the entire dictionary, I have this name, key, and John is a value here. So if I import, I'm importing my file, and there's a dictionary. Inside dictionary, there's a name. Name is a key, and I am printing the value of that name key. And that is John. John is a value. Okay. So this file, this I have created, it is a module now. Why module? Because I am importing this file into another file and I'm using the functions of this file in my another file. That is why it becomes a module. And this is the file created by me. Let's say you want to use my file, so I will share this file to you. And now you can import also. So this file is generated by someone else and you are using the functions in your file. Okay, now you can see this is one line code. This is one line code. If I want to use function, then I have to define it first. But what I'm doing, it is defined in another file and I'm simply importing in my file without writing the actual code. I'm not here, I'm not writing any actual dictionary. I have not any dictionary here in this entire file. Right? Dictionary is another file, is in this file. So now I am not actually writing the dictionary. I'm just importing the parts of the dictionary in my file. Same as when we use OS library, the OS file.
Mm.
One second. When we import this os.py, this is again a module here. Now I can import the OS here. Okay. And I can use the functions, the variables, the methods, the dictionaries from this file to my file by importing it and without actually coding it because it is actually coded by someone else. Now I can simply call the function here. Okay. Here also you can see there's no calling of function. There's no calling at all. Call it here. We can call it here. So that is why we are the models. Okay. Is it clear?
Um, so not yet, teacher. Can you repeat the import OS?
So we have import the OS here. OS is another module here. You can see
Mm-hmm.
file name is module name. os.py. os.py is my file name and I'm importing OS, import OS. Now whatever I wanted to use, I can pick up here. Like we have many functions here. You can see the file is very large. You can see there are like many functions, many functions. And you can see there's no function calling here.
Yes.
Function call is when we call in my actual file, in this file. So if I want to use any function, let's say here I'm using print os dot get cwd. If I search here for get cwd or cwd, there's no function. C maybe there's another file with the os name. So basically what we are printing get CWD. CWD is another function in the OS and we are
Mm-hmm.
importing that function here. And if I print, it will return my current location, which is here. So
Okay.
importing means we are importing all the functions of the module. And that functions we can use in our file without actually coding them because it is pre-coded by someone else. Okay, so this is one example. Let's say I just wanted to use, this is my model here. I just wanted to use function one only from my file. I don't want it to import everything. I just wanted to import function one. So I can also import like using from file underscore one, import function one like this. So from file underscore one is my module name here. Okay, module name means file name. And from file underscore one, I am importing this function only. So if I run this one function one, you will notice hello world, hello world, because of
Mm.
this one. Here with this hello world. Okay. So from file underscore one is my file name, which is our module here now. sorry, sorry. And from here, I'm importing function one.
Mm-hmm.
And this will print the hello world, which is here.
Yes, teacher. Okay, got it.
Okay. So that is a model. And the combination of Python files are known as libraries or we can say packages. For example, these are all packages here. If I run open any package, let's say Let's say we have this package. Let's say this is a package, Flask. Flask is a very popular library. Okay, if I open this one, you will notice multiple Python files. These are all Python files. You can see py. These are all Python files, which means this is a combination of, it is a package, or we can say library. Package and libraries are same only. Okay, which means combination of multiple Python files made up a package. A single file is a module. Okay, so we have two types of modules in Python. We have this built-in modules, which is provided by Python only. Okay, if you want to check, you can use help modules. You can write here in the Python code like this, help modules. In this way, you can see all the modules. Sorry, this is my another file. Let me remove this and run here. Okay, so this will return all the modules. It is generating a list of all the available modules in my operating system. So all the available modules will be printed here. So it will take a while. See, these are the
Very good.
modules. It is generating slowly. Okay. So here we have this, if you're using an taking help, so please see, warning, NumPy. So these are the modules only. Okay, NumPy is a module. This is a Python library is a module. And again, we have some other modules. Okay, like dash table and so on. So it is printing one by one. And it is a
Mm,
very large file. That is why it will take a lot of time to print. You can see this Pygame is another module in my Python. NumPy is another module and so on. So this will print the entire modules in my file. If you want to see all the modules, then you can use your command line. And here you can search for pip freeze like this. So pip freeze will also give you all your modules. These are the modules in my library, in my Python. Okay,
mhm.
some are installed, some are pre-installed. So these are all the libraries. So what is pip here? What is pip here? Pip is a Python package manager. Okay, if I show you the definition, yeah. So we have this pip. What is pip? Pip is a Python package manager, or we can say module manager. What is the purpose of the pip? Pip is mainly for installing the packages and uninstalling the packages. Okay, for example, there's a package. Some package are pre-installed in your Python, like it comes pre-installed with your Python. But some packages are not pre-installed. For example, let's say we have some package. For example, we have package for the networking. Okay, we have the package for the automation. We have some package for the GUI application. So those packages are not pre-installed. We have to install it. So how we can install using pip? So we can use pip install and your package name. Let's say package name is request. This is my package name. It is a package for networking. If I enter this one, you will notice request will, it is already installed in my system. So it is saying requirement already satisfied. So here we are installing request. If you want to uninstall, then you can simply use pip uninstall request. So this will uninstall your package. Okay, so pip is a Python package manager. It is a manager of Python which will handle all the packages. It will install package, it will uninstall package, and it will also update packages, and it will also list all the packages, which is using freeze. With the help of pip freeze, you can install all the packages which are installed in your operating system. Okay, so we can use pip uninstall. We can also use pip list for listing all the packages. We can also use pip freeze for installing, for listing all the packages. Okay, so pip is a Python package manager and it is very important. We will use this pip later on. Like when we have to install any packages, we will use pip. Okay,
Mhm.
so and if there's any module which is not installed, then you have to install it. Otherwise, it will not work. Okay, so this is how we can create a module by using, by creating another file. You can simply import it, import the name of your file, and then you start using its functions. Okay. Is it clear?
Yes, teacher. So later on, teacher, I need to install the pip packages.
No, pip is installed in your machine. Okay, pip
Ah,
is
it's already
installed.
installed.
But if you have to install any packages, then you will
Mm.
install pip install and name of your that name of your package you want to install. Okay.
Okay, first pip install request.
Yeah, pip installed and name of a package. It can be any package, not request. It can be any package. Okay, for example, I can install any other package. For example, pip install pandas. Pandas is another package. So this will install pandas for me. Okay, it is another package. I can use
Mm-hmm.
pip install numpy. Numpy is another package which I can
Mm-hmm.
install. Okay, so these are all pre-installed in my machine. So pip install name of a package you want to install. Okay. In the Python, we have many packages, like packages for every purpose. Like if you want to take a screenshot, we have another package. If you want to use networking, we have another package. If you want to automate, we have another package. So we have like thousands and lakhs of package in the Python. Because Python is open source, that is why we have lots of package. And that is why Python is very powerful because of the packages. We have many packages, many libraries in Python. And because of that particular nature, Python is very popular. Okay, which means Python is used everywhere. In the automation, we can use in the networking, we can use in the cybersecurity, we can use in the web development, in the application development, in the GUI. Everywhere we can use Python because
Mm-hmm.
Python is open source, and because of that nature, we have many packages. Okay, like there are like many developers, they came and they contribute in Python. So they created many packages so that we can simply import it and use it. Okay, so that is why modules and packages are very important. Okay. So is it clear? The
Clear, teacher.
definition and the purpose?
Yes, teacher. Thing clear.
Okay. And how we can create packages? We can simply create a simple Python file. You can create your functions. You can keep anything you want. And if you want to use this as a module, take another file, import your
Mm.
file name. Okay. Import your file name and then start using your functions. Simple. Okay. Now this is the module which we have created by ourselves. Okay. Which is, here you can see create a module.
Mm-hmm.
So this is a module we have created by ourselves. We can also use Python built-in modules, which are very important. Okay, we can import modules. So we have many modules in Python. Some are random. Random modules, we have this random module. Let me show you. So we can import random. Now, what is the purpose of random? Random will generate random numbers. Okay, we have this random module. Then we have this module name math. We have this math. Then we have this module name OS. Then import date, time. Okay, OS we will see later on. But we have these three modules which are important that we can discuss. Now, what is the purpose of import random? Random will generate random numbers. Okay, you will see random numbers are important whenever you use any file. They are important. For example, how to use it? Let's see, we have this number equal. So we have to first name the name of the module, random dot, rand, random. Now, let's say I just wanted to generate numbers from 1 to 10. Okay. And here I can print number. If I run this one, you will notice 1 to 10 numbers. Take no arguments. Okay, it will take no argument. So this will generate any random number. Okay, a floating number. So this will generate number from in the middle of 0 to 1 only. Okay. If I run again, it will every time it will run a unique number. So this
Mm-hmm.
is one number. If you want to generate a range of numbers, then you can put random dot rand range. So it will generate range of numbers. Let's say I just wanted to generate 1 to 10 numbers and let's say 6. And if I run again, you will notice 1. If I
Mm-hmm.
put here, let's say I just want to generate 5 numbers. It is a step argument. It is a step argument.
Mm-hmm.
So we can put this in a range of like in a loop. But for now, we can generate random numbers from 1 to 10 randomly. If I run this again, you will notice again a random number. We can also generate integers. I can put here random dot rand int. This is for the integers. So it will generate integers from in the middle of 1 to 10. Okay. So we can generate numbers with the help of random. Okay, random dot rand int, then random dot rand int, and random dot random. Okay. We have also one more feature, which is random dot choice. Let's say we have a list of numbers or list of any list of fruits, let's say, okay, which contains some numbers. Sorry, some fruits list. Okay. Now let's say I just wanted to randomly choose any element from the list. So I can use here print a. I can choose a random dot choice from A. So this will randomly choose any element one by one. Okay, let's say if I run this one, it will choose apple. If I run this one, it will choose any other grapes. If I run this one, it is choosing grapes again and again. Apple, okay, now apple, it is choosing now grapes. So randomly it will choose any any element from the list. You can provide list also, you can provide string, you can also provide numbers, you can also provide tuples, dictionary, set, and frozen set. Anything you can provide here. So random dot choice will choose elements from your own creation, from your own list, tuple, dictionary, set, etc. That is random dot choice. Even you can put like this one. Let's say print random dot choice. I just want to choose from numbers. Let's say here I can provide list of numbers. So here I'm providing a list of numbers. So this one will choose any random number from this list. If I run this one, you will notice 8 here. If I run this again, you will notice 1 here. If I run this again, you will notice it is choosing randomly. Okay. So now what is the purpose of random? We have many purpose. Okay. It depends on your use case, where you are using. But random is very important library. Okay. Is it clear? How
Yes,
we can
teacher.
use random? Simply
Yes.
import your module. And whenever we are importing the module, we have to name this random. Now, what is random? Random is another random file. Okay, random.py. If you search on your operating system, you will have also this random.py. So we are importing this random file. This is a module. This is a whole module. And we are importing this feature, the functions of this random in our file, in this file. If I show you the feature of choice, let's say, you can see we have this random.choice. Okay, so here you can see we have this function here, random.choice. So that's what we are using. Okay, so we are importing this file. And what is module? Module is just name of that file, random. Okay, name of that file, and then you have to mention the name of that file and then choice, like which function you want to use. If you remove random from here, then Python will not identify what is choice here. So you have to specify random is name of my file, and from random, I just wanted to import choice. Choice is a function within the random file. Okay, same as random dot rand int or random dot rand inch. Okay. Then apart from this random, we have another library, which is again very popular, which is math library. Okay, we have this OS library, which we have already discussed. In the OS, we can import OS name. Okay, let me show you this. Again, we can simply import and we can start using. We have this print, we can import OS dot name. So this will print the operating system name here, which is, there's something wrong. Okay, OS.NET. NT, which is Windows, NT, which is Windows new technology. It is a Windows system, that is why it is printing Windows NT. Same as we can print mkdir for creating the folders. We can print get cwd for getting the current working directory. We can change directory. We can remove directory and so on. So we can run any kind of commands here. Okay, so that is this OS. We can rename also, that we have discussed already how we can rename it. So with the help of OS also, we can perform many functions. These are very few. If you want to search how many functions are there within the OS, then you can simply search for the OS module here. Okay, you can see. Here we have this OS module. In this OS module, we have many functions, like many functions. We have this set NS, we have this set GID, set UID, GID, and so on. Put environment variables, init groups, get UID, and so on. We have many functions here. So this is a module. Okay. In this module, we have many functions. All you have to do is you have to import your OS and then start using the functions. That's it. If we have no OS library, then what we have to do is we have to create the entire function first and then we have to use it. But we have predefined function in another file, which is OS, and we are simply calling it and calling the function. That's it.
Mhm.
Then we have this import math. Math is also important. Like we can perform mathematical operation with the help of math library. What kind of operation? We can find min value, max value. Some math functions are built-in math functions, which means if I remove the math library and if I use it, let's print, we can use, we can create either a, let's say we can create a list here, let's say a equal. In this list, we can keep some values. Okay. In this, we have some numbers here in the list. So I can put here max and I can provide a here. So I just want to find the maximum, like the largest number within this A. You can see 66 is largest here. You can find minimum also. You can use minimum of A. You can see we are doing this operation without importing the math library, without importing, because these are some pre-built features. If I want to round number or seal number, then we have to import math library. Okay. So again, in the math library, we have many functions. If you want to search, you can search it. Okay, which is math, Python. Okay, so we have this math, which contains mathematical functions. Okay, for example, seal, this is for rounding off, combination, copy sign, fevs, factorial, floor, and so on. We have many functions. We have this, we can sum numbers. For example, we have this math dot sum. We can sum numbers, like we can add numbers. Here we can provide A. A is my list here, and I can print here the entire thing. So I am adding all the numbers in my list, 1 plus 2 plus 3 plus and so on. So if I run this one, you will see the sum of numbers. Sum. I think it is not defined. We can use sum. Let me see the name of that sum. There's a function known as sum. I think that is not, that is without math. Yeah. That we can also use without math. We have the sum and A. So this will sum all your numbers, 140. Let's say you want to round off any number. Let's say we have this number B equal 5.6. You have to round off this number. So you can print math dot floor or round. You can round number from B. So this will round off your number, which is it will print 6 here. No attribute rounds. Okay, so I think we have this floor here.
Float, I
Floor.
think float.
So floor will round off a number. Okay, it is previous round. It will provide a previous number. Same as with seal here. Seal will round a number in one way forward. If I use seal here, so it will become 6. You can see 6. Your 5.6 becomes 6 in the seal, and your floor, it will becomes 5. Okay, so floor will round one step forward, backward, and seal will round one step forward, like this one. Same, we can define the value of pi. Okay, we have this math dot pi. Okay, we have this value of pi here, which is this is the value of pi. Okay, which is 3.14, our default value of pi. Same as you can perform any number of operation. We can find out power of any number. We can use square root of any number. We can use seal and floor. We can use pi and so on. So again, we have many functions. They are like limitless functions. It's all about it depends on a scenario. like what kind of functions you are using. So you can simply come on the documentation, you can search for your function you are searching. Even here
Yes.
this number like sin cos, this sin, with this factorial, we have this sin, okay, we have this cos and so on. Okay, trigonometric functions, we have this, okay, a cos, a sin, a tan, a tan,
Mm-hmm.
and so
Very
on. Like we
fun.
have many functions.
Yeah, it's very fun, teacher, huh?
And we have this gamma, L, gamma, pi, and so on. See, these are all math functions.
Mm-hmm.
Okay. Apart from math, we have one more library which is important, which is date time.
Mm-hmm.
Datetime, we can perform datetime operations with the help of datetime library. Without datetime, we cannot perform any datetime operations. Okay, so what we can do, we can simply import datetime.
Mm-hmm.
Now, let's say we want to print the current date and time. So we can print datetime dot datetime dot now. So this will print current date and time. So you can see today's date. Okay, this is year, month, date, and this is hour, minute, and seconds. So this is
Mm-hmm.
current date time. So you can also use a alias. What is alias? You can see we have to write date time in the full form. Okay, like date time again and again. So what we can, so we can use a alias. Import date time as dt. Now dt becomes a alias, or we can say a short form of date time. So whenever you want to use date time, you can simply use dt. It is a short form. Okay, dt. So it will also work. So if there's a library and the name of the library or the function is, sorry, the module name is very large, then you can provide an alias. Alias is known as S for alias. It is a short form for your module name. Okay. You can also provide, you can put any alias here. It's your choice. You can put D here, DTTT. You can provide any alias here. Okay. But you have to use this alias everywhere you go. So we can also use alias. In the alias, it is not compulsory to write datetime again and again, because datetime is a very large word. So in place of datetime, we can also write dt. It is a short form. Okay, so it is known as alias. So it is for just a short form. Okay, just for using a short form. Then we can use here, we can also extract objects from the datetime. Okay, we can also create our own datetime. For example, let's take this example. We can print here dt dot datetime. Now I just wanted to print date as 2024 month 5th, or let's say month 1 and date 1. So you can also print your own date time. You can see this is my date time which I have printed here. Okay, here 2024 1 1 and no time here. You can also print your time as well. Okay, so in the date time also we have many features. We can extract objects from the date time. Like we can extract like year, month, second, and so on. For example, let's say in the date time now, we have here, let me save the file. In the date time now, we have this year, month, seconds, and we have this hour, minute, seconds. So what we can do, let's say I just want to extract year from the date time. Year from the date time. So what I can do, I can first create a variable x equal, and here I can put this part in here. Okay. Now what I can do, I can print here x dot stuff time. What is stuff time? Stuff time will extract any kind of object from your date time. Let's say I just wanted to extract year. So I will put here first year. So this will extract year. What is year is 2024. You can see 2024. If I apply here month, so this will extract month. If I run this one, you will see month here, which is 6 months. It is June. You can also use month name. I think month name is not defined. It is not there. You can also extract day here. Which day it is? It is date, system date. Okay, you can extract year, month, and date. Same as you can extract any other part. Let's say stuff time we can use here, and let's say here we can use percentage A here. Now, what is percentage A here? You can see Sunday. So, what is today Sunday? So, these are known as stuff time. If I show you, these are the stuff time we have. For the small a, we have this weekday. Okay, which is it's in the short version. If we have this capital A, it is weekday in the full version. If we have this W, we have this weekday as a number. If we have this D, day of month, B, month name, is capital B, month name, full version. If I put here capital B in place of capital A, you will notice month name in full version, which is junior. If I put here small b, you will notice month name in short version, junior. Okay, if I put here W here, percentage W, you will notice 0. 0 is the week of the day. It is starting from Sunday. Sunday is 0, Monday is 1, Tuesday is 2, and so on. Okay, it is as per the Python. Python takes Sunday as 0, Monday is 1, Tuesday 2, and so on. That is why we have this Sunday 0. Okay, month as a number also, you can print M, Y year in short version, Y in full version, hour, minute, second, and so on. You can extract anything. Okay, so with the help of this stuff time. So I have provided a list of all the stuff time. If you want to extract, you can extract anything here.
Mm-hmm.
Okay, let's say you are creating a program for configuring your firewalls again in a network, and you want to set a time that at this time you want to configure again and again, or you want to update. So in that case, you can use date time here. Date time is for handling date time in your Python. Okay, you can handle, you can update, okay, and so on. We have like many features that we will see. It is like an introduction of date time. Is it clear this much?
Yes, teacher, very clear and very fun, super fun.
Okay. So again, we have many libraries. Now, if you are confused about how many libraries we have, simply search for it. Let's say you are
Yes.
creating any program and you want to take a screenshot of a user. So you can search for screenshot Python. Simple. If there's any library, you will see it. Let's see. We can see we have this documentation, how to take a screenshot. Or we can search for screenshot library. So you can see there's a library of screenshot, you can see, in the Python. So this is known as pip install PyScreenshot. You have to install it first and then you can use it. And this is the official documentation. You can click on this one and this will take you to the official documentation of screenshot. You can see goal is PyScreenshot tries to allow to take a screenshot without installing third-party libraries. It is a cross-platform. It is only a pure Python wrapper, a thin layer over existing backends. So we can run this PyScreenshot anywhere in any library, in any operating system. So we have many libraries. You can simply search for it. Let's say we have library for automation. So we can search for automation Python library. Simple. So we have many library automation libraries for Python. We have Selenium. You can see Automate. Automate is another library. You can see pip install Automate. So Automate is a general purpose automized library for Python. Its objective is to offer convenient and robust object-oriented programming, which is OOPS framework for complex state machine system. It will automate your design, complex automate. You can automate it. You can automate the robotics projects. You can automate the automation projects and so on. All you have to do is install it. Okay, and use it. This is the official documentation. You can see. So with everything, with every library, we have fully documentation also, so that you should know how to use this particular library. Because as you can see, it is not compulsory to, to understand all the libraries. So that is why we have this particular documentation. If you're stuck at somewhere, if you want to like use any library, if you want to check out some functionalities, so you can simply check out the documentation. So it is a Python documentation for automation.
Mm-hmm.
So this will tell us like how to use this library. If we are stuck at somewhere, we can simply use it. Okay, how we can integrate, how we can use it, how we can automate Hello World, how we can automate the original application, and so on. So we have thousands and millions of libraries. Like we have libraries for every purpose. for each and every purpose, like even for the small purpose and for the large purpose. And if you don't find any library, any module for your own purpose, create one. Create your library, create your own library and upload it on the Python source code so that you can also contribute in the Python library. Okay, so they're like developers like you and me only. They are all over the world and they're contributing in the Python so that everyone can use their library, their packages. Okay, that is why the importance of modules and libraries are very important because it will allow us to use Python everywhere. We can use Python in all sort of purpose because of this library and modules. Is it clear this much? Any questions?
No, teacher, very clear.
Okay. So we have one more concept which is remaining, which is regular expressions. And that is a very complex topic. Okay, so that we will continue in the next session because that will take around 1 hour more in
Mm-hmm.
completion. Okay, that we will continue in the next session. So we are only left with one more module, which is regular expression, and then we will complete the entire core Python. Okay, so in the next weekend, we will discuss about the regular expressions and then we will discuss about the question and answers. I will provide
Okay.
some questions of these modules which we have discussed yesterday and today so that you can start solving the answers. Okay,
Yes, thank you, teacher.
thank you. And try to like answer the questions. Okay,
Mm-hmm.
and share it with me.
Yes,
And
teacher.
in the next session, we will solve it. Okay,
Yes, thank you, teacher.
thank you so much. Have a good
Okay,
day.
bye bye. You too. Bye.